working.
Oh.
My channel.
This one's kind of interesting. I don't think it's a medium low-key.
You don't. It's like easier or harder?
But you could low-key write this in like 5 lines if you try it hard.
Okay. Okay. Here, let me send you. I don't know. In case you want it, there's my stream. Okay. Cool. Now let's take a look at the problem. Okay, cool. Let me stream for you. Alright. Alright, let's take a look. So, we're given an integer array nums of size n, where n is a multiple of 3, and it is a positive. Oh, and we also get a positive integer k. Alright. Divide the array nums into n divided by 3 of arrays of size 3 which satisfy the following condition. The difference between any two elements in one array is less than or equal to k. Return a 2D array containing the arrays. If it is impossible to satisfy the conditions, return an empty array. And if there are multiple answers, return any of them. Okay. So let me just make sure I have this right. So let me take a look at the example really quick and see if I like understand it. So we're given this integer array nums here, and it's divisible by 3, right?
Yep.
And we have to have create subarrays, or we have to like divide it into like multiple subarrays where the difference between any two elements in one of the array, one of the subarrays is less than or equal to k. Okay, I see. So since k equals 2 here, the maximum difference between any two items in any array has to be less than or equal to 2.
Yep.
Okay, cool. Wait, let me turn you up real quick.
Not bad. I can move my mic closer.
Alright. And then if that is not possible, we return an empty array.
Yep.
And if there are multiple answers, return any of them. Okay. So let me see. Thinking that, well, we have to iterate through all do we have to iterate through all the elements? Let me think. I think. Well, I feel like yeah, because we have to use all the elements in the array. So it's at least O of n. I'm thinking like right now something like pretty like high level approach is like we start with the first number.
Yep.
And then we basically we're gonna want to have the numbers that are like close to one another because no matter what, we want the difference between any two elements to be less than or equal to k, right?
Yeah.
So if we do something like sorting the array, for example, I'm not saying that that's the solution, but I'm saying if we did, it would probably like have us a lot closer to a solution if we had one, because what that would do for us is, if there is a solution, it probably like, probably would be that, honestly, because we're going to minimize the difference between any two elements like consecutively, or any of the elements like that appear in the subarrays.
Yeah.
If that makes sense.
Yes.
So, at the very least, I think we know straight up that we could probably have an n log n solution just by sorting the array. And if the output isn't valid, then we can just return an empty array.
Yes.
I'm trying to think, is there a way to do it a little better? Trying to think. I was thinking for a second, maybe I could use like a set, but that wouldn't work. I'm thinking maybe I don't think a hash map would really be very helpful. I think, let's see, stacks, queues don't seem to be very useful here. In let's see, let's see, do you think it'd be best for me to just like try to implement the just an n log n solution and then
just go for it.
Okay. So there's like a sorted method, right, for lists, I think.
Yeah, I'll save time. I think you can just do dot sort.
Okay.
Yeah, and it'll
Like
just sort
that?
it.
Okay.
Yep.
So let's see. Once we sort it, so the solution I'm thinking of right now is once we sort our inputted list, we're going to basically, we can kind of ignore the middle item. We just have to check to see if the last item minus the first item in each subarray is less than or equal to 2.
Yep.
Because that would be like the highest number possible in the subarray and the lowest number possible in the subarray, right? And so if we do that for each of them, then we will, if they're all valid, then it would be true, or then we can like it'd be a valid subarray, or it satisfy the condition, whatever. So let's see. So from sorting first, we would then divide it into divide nums into subarrays of size 3. And then for each subarray, we would subtract last minus from, or subtract last item minus first item, and check if that is less than or equal to k.
Yep.
And then I guess we could have like a return, I guess like an ants list that we can use, and then if it is valid, then we can just put it in is valid, put in like the answer like list, and then if not then the answer would just be invalid, right?
Yes.
So we can just return, or else return an empty array, and then at the end we will return ants. Does that look about right?
Yep. Looks
Okay.
pretty solid.
Okay, cool. So from here, let's see how we do this. So I guess we could honestly just so wait, so just to clarify, does nums.sort just make nums like sorted?
Yeah.
Okay, cool. All right. So like I
So
don't
no
have to do
nums.
anything to this now, and like
No.
after this line nums is sorted, right?
Yep.
Okay. So I guess we do this, since it's a multiple of 3, we do this length divided by length of nums divided by 3 times, right?
Mhm. Yep.
Length of nums divided by 3. We are going to define the subarray as, or I don't know if, hold on, let me see if is range what you want. Yeah, because it'll go that many times. So this would be like subarray 0, or like so I would just be the index of each subarray.
Yeah.
And so subarray would be defined as it'd be the nums at I Let me think. It's so I'm trying to just like see if there's like a cheeky way to like the number. So for subarray 1, it's going to be it'd be nums at 0, nums at 1, nums at 2.
Yep.
Then it'd be
So maybe think about what the first index is going to be every time of each one.
0, 1, 2, 3, 4, 5, 6, 7, 8. It's going to be divisible by or it's going to be like a multiple of 3 as well. So you do like 3. I'm trying to think. Would it just be? Oh my gosh, let me write this down. Like, okay. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. Right?
Mm-hmm.
And then
Yep.
we'll have. We're gonna start at I equals 0.
Mm-hmm.
And then once we get to I equals 1, we're gonna have, so let me think. So it's just three times, let me see, 3 times 3i plus 1, right? 3i plus 2. Let me see if that works for the next one. Yeah. So 3 times 0 is 0. 3 times 1 is no. It's terrible. What am I talking about?
You have the right idea. I think you just like kind of wrote it out in a confusing way.
Yeah. It's. Oh, I mean.
Yeah, you have the idea.
Yeah,
Yeah,
I mean,
the
it
3i and then 3i
3
plus 1.
plus
3i
1
plus
plus 1 because it's 1, but I is just the, like, it's gonna be the it's gonna be 0 for all 3 of them. Yeah. Okay, cool. So that should actually work, right? 3 times I plus 1, and then 3 times I plus 2. Okay, cool. So that should give us each subarray, and then for each
What exactly? So what is subarray going to be the first time when I is 0?
On I 0, it's going to be 0, and then 1, and then 2.
Right. So.
Oh, right. Oh, good catch. Sorry. Nums at 3 times I. Yeah.
This works, but do you also remember how to do a substring of an array?
It's like what?
Like get a portion of it. Because that'll shorten it a good amount.
Yeah, it's true. I don't know if it's right, but it's I forget like. No,
like how would you get like
I forgot.
the okay, yeah, it's chill.
It's fine. I know that there's definitely a way to do it. It's like with the there's like the fucking whatever, and then there's like one of these 3 fucking values. but I just forget which one does which, and like how to use it correctly. So it's fine. So for each subarray, so we're going to.
Also, just another quick thing. So, what are you doing with subarray?
I'm gonna verify if it's valid, and then if it is, then I put it in answer. If not, I return empty string or empty array. So I mean, I don't really need that, but so if subarray, I think it's that is the last item.
It's
Is
just
that right?
-1.
Huh?
It's just -1.
Oh, becomes. Subarray at 0.
Yeah. I mean, you also know in this case that the last one is just the third one.
Yeah, that's true. Ah,
Yeah, but it doesn't
well,
really matter.
yeah. Is less than or equal to k. Then put it in ants. Right?
Yep.
Else return. Okay.
Nice.
I think that should work. I'm looking at the constraints to see if there's any like edge cases I may be able to think about.
What do you think about edge cases? Also, like, if you think you were to get some sort of error here, but like not a major error, like a like a one-off error, where you're just like very slightly off, where do you think that would be?
If I was to get an error here,
Like very close.
if I was to get an error here. I think.
Or just like typically, right?
Yeah.
When you're dealing with like differences, or is asking for like less than or greater than, or you're getting like indices of an
Yeah.
array, right? Like usually you might get like an error around there,
Uh-huh.
right? Depending on the wording, right? They might say like difference is less than or equal to or greater than or equal to.
Oh, right.
So usually when you have anything with like less than or equal to, or you're doing a difference, or you have like near the edge,
Uh-huh.
right? You have like a +1 or like
Oh,
anything
it's,
like that.
yeah.
Yeah, yeah. But I think the way you wrote it here is like pretty foolproof.
Yeah.
Like sometimes people try to like
That's
kind of like
true.
rearrange it,
That's true. No, that makes
and
sense.
so they like mix up the signs. But yeah, so if you were to look through this,
Uh-huh.
then I would like run through an example with like the if statement, for example,
Yeah.
or something like that.
Okay. Yeah. Yeah, no, I've run into that before actually as well. So
Yeah.
that's a good point you brought up.
So like before you run it, if you want something to check, like check like the array indices or where you're actually doing the calculation where it's easy to have like a one-off error, and they'll be like, oh, like good catch or good looks.
Yeah.
But I think you should be fine. You can just run it. I also got that initially.
So can I be into it? Do I just need to? Do I have to do like? Cause wait, I gotta check. Is so n is always a multiple of 3.
Yeah. But
So
what happens? What did the error say?
float cannot be interpreted as an
Float.
integer.
So you know
So
in Python, what are the two types of division?
right, is integer division like double?
Yeah, but it doesn't really matter here. It's not gonna affect.
Like that?
Yeah, you can see that.
Okay, cool.
Nice.
Submit. Nice.
LFG.
Pretty happy with that, honestly.
Yeah, that's good.
Yeah, I like that one. I felt like I like. I mean, I did pause here and there to think a little, but overall, like I
Mhm.
felt like I kept talking.
I think that
Um,
you did was right, and also your pseudocode was good.
yeah. Um, I don't know. I'm glad that I gave a little bit, at least a little bit of thought. I don't know.
Hmm.
Am I allowed to ask like my interview is like, is it all right if I like just kind of get started with the solution I have in mind like right now?
Yeah, I mean, you don't have to ask. You can just say like, I'm just gonna start with it.
Yeah,
Um, and then
cause
you'll do it first, and then you look it over, and then if you think that's a better solution, then you can always do it after.
yeah,
Whereas like we did last time, as you're doing it, you can say like, oh, I know how to do it this way, and you can say like, oh, I know there's probably like a, I could do this other way, which might be slightly faster, but I'm just gonna do it this way for now. I was like acknowledge like what you're thinking in the moment while you do it.
yeah. Okay.
So it's like, I mean, it can be like even some of the minor things, like the way you did the subarray instead of doing like a subgroup, the substring of it. You'd be like, I don't really remember how to do it. I'm just gonna do it this way, but I'm sure there's like another method for that,
Yeah.
you know.
Wait.
But
So
yeah.
so how would you get like the first 3 elements or whatever?
Oh, like if you wanted to just get like any index, like how do you get from like the first index to the third index? Just one colon.
Oh, right. It's just like 0 to 2.
Yeah, so that'll give you 0 and 1, right? It doesn't include the last one. And that's
Oh.
it. So you've just done nums like 3 times I colon 3 times I plus 3.
I see.
So you see the solution that I sent?
Let me see. Yeah.
So yeah, I just did plus 3. And like yeah, like for example, the first time where I appended the the subarray,
Yeah.
like I did like plus 2
Yeah, I see
because I
that.
forgot that it
Yeah.
doesn't include the last one. Or yeah, like but then above I just copied the plus 2 from that
Yeah.
because that worked. But yeah,
Nice.
just like stuff like that.
Wait, so I forgot. Like, do you remember what the last like there's a 3 colon version, and
Oh,
I've seen.
the last one is like the step,
Oh, right. Okay. Okay. I see. So
so you can like skip
skip.
them in
Yeah.
between.
So if it's like 0 to like 10 or whatever, it'd be like 0, 2, 4, 6, 8. Yeah.
Yeah.
Okay. Cool. I just wanted to.
Like if anything, like I feel like talking through your logic is definitely the most important part.
Yeah.
Like if you say just say you're sorting, you're gonna sort it, but you don't really tell them or explain why you're sorting it. That doesn't really help you that much.
Yeah.
You might get it right, but if you tell them like, oh yeah, like you sort it to get them as close as possible, and if even that doesn't work, then like there's no other way to get them
Yeah.
closer or less than A.
Yeah. For sure.
So yeah, no, that was really solid.
Thanks.
Nothing really to critique at all.
Nice. I'm happy with that one today. Honestly. Shit.
They low-key like gave it away with that first example though.
What do you mean?
Or how like they took it and it was just sorted.
Yeah. Yeah. I.
Like I probably would have thought of it. I thought of it like pretty quickly, but like just seeing that immediately made me think like, okay, wait, should I just sort this? And I was like,
Yeah.
oh yeah, I should sort this.
Yeah, I mean, it's a good example. Like, but, you know, it's just like, yeah. I mean, my
Good
mind
one.
didn't immediately jump to sort. I actually thought about it for a little bit. Like, I saw this, I saw the example, honestly. I mean, I guess you jumped to it, but I don't know, for me,
Yeah.
I
Oh, I
thought,
think that's another big thing that I do is whenever I read them, like I'll first read it, but then like I would go very deeply into like the examples that they give
yeah,
because sometimes like the description can be kind of bad,
yeah, sure.
like not nuanced.
Okay, cool. Sorry for
Okie
holding
dokie.
you up for dinner, but
No,
thanks
no,
for
you're
doing
good.
this with me.
All right, I'll see you.
All right, later.
Peace.
Peace. Okay, cool. Let me see. Holding
Okay.
you up for dinner, but
No,
thanks
no,
for
you're
doing
good.
this with me.
All right, I'll see you.
All right, later.
Peace.
Peace. Let's see. Be careful. Okay, let's go back to neetcode. Continue to work through this. Oh shit, there. Okay, so we're gonna do binary search. I've done this problem before. Pretty sure my solution was trash, but it's an important problem. It's easy. Don't get it done. Let's do it. So, given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. You must write an algorithm with an O log n runtime complexity. So if our target is 9, we're gonna have to find the index. I see. So O log of n means we can't sort, and we can't just find the index of 9 because that's O of n because it's a search algorithm. So because of the title, we could definitely binary search kind of so my thought process here is we'd start in the middle and we divide it kind of in half. We start on the left or the right, choose one, but we just have a pointer, I guess, or whatever. And if the number is higher, then we split it and move to the right, and we go to the middle of that, and then search it. Boom. 9. Yeah. Okay. So I'm thinking about how we get the index afterwards. To get the index, what I think we do is while we search, we use the length to keep track of it. So we use the length of nums to kind of keep track of where we are. So, let's say we start on the left. like so if it's an even number, let's say we start on the left. I think it's kind of arbitrary which one we choose. Doesn't really matter though. So we're gonna do start at 3, right? And if we'll do is there a floor function? Oh. Okay. So my thing of process here is divide okay. Actually, let's think a little bit more about the approach here, and like how I would possibly go about this. So all the integers are unique, which is actually useful. It's already sorted, which is good for us. The length, so we can't have an empty array here, right? Because it's greater than 1. Alright, and that is our limit. So let me think if maybe recursion is possible here. I don't know if it is, but let's see, our base case would be if I guess the if the lit I actually don't know how to do recursion in Python, because I don't quite get how the self thing works, but whatever. Alright, let's just do it regularly. I think there is a recursive solution. Yeah, there is, but let's not use that for now. So we're going to split nums into, or not even split, but go to okay, so we're gonna have to go to the middle of nums, right? And we're gonna find middle as if length of nums is even, then middle equals, let's say the left one, right? So nums, length of nums divided by 2, floor division, right? And then I guess if it is, well, okay, let me think. So okay, let's see. So since it's 6, right? Length of nums is 6, divided by 2 is 3. So 0, 1, 2, 3. So I guess that would default to the right one. What if it was 7? 7 floor division by 2 would also be 3. So I guess we can just use the right one, because we can just use length of nums floor division by 2, and no matter what, we're gonna get the right one, or yeah. So that's fine. Go to the middle of nums, right? And if middle is less than target, I definitely want to do this recursively. Like I'm like itching to do it recursively, to be honest. So I guess let's just do it recursively. So our base case is if nums equals target. Oh no, because never mind. Because we have to find the index. So if nums at middle is less than the target, so if it's less than our target, that means it is on the right side. Also, if nums at middle is greater than target, go to the middle of the left side and repeat. Else return middle, right? And if it does not exist in this, then we return -1, right? So I guess we can put all this in a while statement, like while nums, or what? So we're gonna have to define if okay, I mistakenly assumed that the solution would be in the array no matter what, which is not true because we're going to return -1. So we also have to keep track. So okay, we kind of have a couple different tasks here. So we have to keep track of middle. Pointer is, and we also have to ensure that target exists or doesn't. Okay. Okay. So we're gonna have a middle pointer, I guess. Just at -1 arbitrarily. we can actually just set it to length nums divided by 2. So okay, so let's clarify what the middle of the right side means. So sorry, I'm getting kind of stuck here on how to go to the right half of it. Dude, I'm getting kind of stuck here. Okay, so I'm actually thinking now about kind of like a different approach right now, where we would have to, I guess, so just because we're trying to find the index, we can kind of just ignore the actual values, and since we already know that it's sorted, and so I'm thinking, oh, we can have answer be, like, let's just set it to -1, right? And we have middle, and what we do is we continually go through and we add to ints. If that makes sense. So like this, right? So we'll have a middle, and we're going to divide nums, the length of nums, by 2, right? And so that's going to give us this 3, which would be the 4th index technically, right? and we're gonna see that, oh, we haven't reached our target, so anything above it is, we can just add 3 to our ants, right? So if middle is less than or equal, or is if nums at middle is less than ants, or then is less than target, then we can just add 3 to ants, or we can add middle to ants, right? Because we know it's going to be on the right side. On the other hand, if nums at middle is greater than the target, we know that it's still in the bottom half, right? And then we can just set middle to middle divided by 2. So okay, look. And then here we just do middle equals middle divided by 2. Else dude, I don't know, man. It's always these like simple problems that like frustrate me so much. Okay, let me get some water and then I don't know. I'll come back and try to reapproach the problem and actually work on it properly. Karate chop that beat. I'm not gonna say it's like. Okay. So. Hello? Alright. So. Try this again. Right. So, we know what the problem is. Right. And given an array of integers nums, which is sorted in ascending order. Okay, I'm not gonna fucking repeat the problem again. We know what the damn problem is, bro. Let me think about what we have to do in order to solve it, right? Yay, binary search. Okay, cool. So what we're going to have to do is we're going to have to search this array in halves, right? So we're going to have to continuously check, you know, the half of each array. And what that means is we're going to compare the values for left and right. Because we're going to have a target and we're going to see. We're going to have a pointer somewhere in the middle, right? And if target is less than, if this middle, like whatever we choose, is less than target. If it's less than, then we know it's in the upper half. If it's not, then we know it's in the lower half, right? Clearly. So when it's in the upper half, we're going to take the middle again, and we're going to see if it's in the upper half or lower half. And if it's in the upper half, we're going to compare the middle to the target. If it's greater than target, then we can move down. And then we'll have that. Okay. And so we're going to have to keep track of this middle pointer, and that will be the index that we have, right? So we're going to have a middle pointer, which I'm going to define as the length of nums, 2 divided floor division by 2, right? And what that's going to do for us is that if it's an odd array, if it's an odd array, like 5 nodes for example, then we're going to get the middle, which is, because it's going to be the length of nums, which is 5, divided by 2, which is 2.5, and the floor division is going to be 2, so it's going to be on index number 2. From there, we're going to compare nums at middle to target. So if nums at middle is less than target, right? So if nums at middle is less than target, which is 9, we're going to set our new middle to the upper half. So middle is now going to equal our current middle plus plus divided by 2. So since we're at 2 right now, we want to set it to two. Dude, this is so fucking confusing. Ah! Okay, right. Let's just work here. Right, let's assume our target is... Okay, so we have this. And right now, our middle is at 5. Once we do this, right, we're going to have a new middle. And since we know it's above 5, we're going to... Gosh, dude, let me fucking draw this in paint, bro. This will actually help me, I think. Paint. Okay, cool. So we're gonna have zero. Okay. Let me just take this. Put that in here. Okay, cool. So this is index 0, index 1, 2, 3, 4, 5. Right? Cool. And what we're going to do with this is we're going to get to the middle, which is currently 3. So we want to get the new middle, which is this. Of you know, since it's like above this. So we're going to have to add onto middle. I think it'd be easier if I had like a bigger array, honestly. Just like do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sure. 1, 2, 3. Let's do 13. So our half would be at 7. I think. Don't get me wrong. Right? And so we need to get the half of this. So we do 7 plus 7, like plus middle divided by 2. I'd assume that'd be the case, right? So again, 7 floor division by 2 is equal to 3.5. So we add 3. Yeah. My only concern is with the smaller one, we do 3 floor division by 2 is equal to 1.5. Or, right, which is just 1. And so it would only add 1. Okay. I wonder if I add a 1 to middle, right? So if I did 4 divided by 2, it'd just be equal to 2, right? So it'd be here. And we just add 1 to 2, it'd be 4. Right, no, but it'd go 1, 2, 3, 4. That's kind of what we want to be consistent, right? So we do plus 1 divided by 2. Okay, cool. Nice. We'll do this, and hopefully it should work. Alright, nice. Let's close that. I don't know why my Chrome keeps doing that. So else if nums at middle is greater than target, okay, so now if it's greater than target, which means it's in the bottom half, let's assume it was 0, for example. Then we would have to set our new middle to 3. It'd just be middle. I'm thinking it's middle divided by 2, right? 2 is equal to 1, so that'd just be 1, right? I'm assuming it's the same for this. So middle divided by 2, so 7, 4 divided by 2 is equal to 3. Right, okay, now that sounds right. So middle is now equal to middle 4 divided by 2. Right, and else. And so okay, we'll deal with that after. We can adjust our thing after. But assuming it exists, once we get to that, now the only other case would be if else return we just do middle. Just return middle, right? So that'd be the last case. So now we need to get to the point where we need to check if it exists or not. Okay, let's just check to see if this works for our current case. Right. So we're gonna start at 3. So middle is length of nums divided by 2, which should equal 3. And so that'd be at 5, right? I guess we'll do while middle is not equal to target. Whatever, it's fine. We can just keep the else because we know it's gonna be there later. But so it's gonna start at 3, and while middle is not equal to target, it's not. Or nums at middle. It's not equal to target. If nums at middle, so if 5 is less than target, which it is, we're going to set middle plus equals 4 floor divided by 2. So that's now 5. Right? So loop again while 5 or while 12 is greater than target. We'll do middle equals that's not quite right. Middle divided by 2 is going to return 2.5, which is here. This is fucking anal, bro. Would it just be minus equals? I don't know. Honestly, I think I'm at a point where I'm just kind of headbanging. Like, I'm making a little bit of progress, but like, I feel like it'd just be easier to understand it. Okay, unfortunately we failed. We'll come back to this soon. So our issue is we had the middle, but we didn't have a set like low and high. So I mean, I was kind of, oh my god, I wasn't showing the paint, but yeah, like we should have a pointer stay at this. Right, and so we'll have the range that we're actually looking at. So it start at 0 to 5, but once we narrow it down, we're gonna have it between 3 and 5, and then okay. Yeah, IDFK, bro. IDFK. So avoid an infinite loop. Let mid equals. Okay, let's check this. Low. Okay. So yeah, let's loop this too. So that mid equals low. Right. So let mid equals low plus high minus low divided by 2. So, okay. High minus low, 5 minus 0 divided by 2. It's 2.5 plus. Oh, okay. So I guess it's using the left. Right. So if target is less than. So if target is less than this, it's not. Else, low is now mid. And oh, and high is mid. Okay. So now mid again is low. 2. So high minus low. 3 divided by 2 is 1 plus 2. 3 shit. 5 minus 2 is 3. Divided by 2 is 1 plus low is 2. Low is now equal to mid. Now mid is now equal to 5 minus 3 is 2. Only 2 is 1. Low is mid. Target is equal to nums. The target is less than, which is not. Else low is now mid. Then it doesn't shrink all the way. Okay, I see. So it's better not to. It's just to shrink. It's just to set high to mid or low to mid, but not to do the other way around. Or it's not to. Yeah. I think the gem here is. So. If the logic fell into the else statement. The choice of mid and our shrinking logic has to work together in a way that every time at least one element is excluded.
Someone just hop on.